So looking at this question, basically we are looking at two types of equation. One is a log equation, abbreviation, and one is an indices equation. And what we want to do is to solve for the value of A and B. So there are techniques that we'll use here, but in both questions, in both equations, the idea and the principle behind is the same. That we try to convert to the same base. We try to convert to the same base. All right. For indices, the laws will work mainly if you have the bases to be the same. And similarly for log, you also have the bases to be the same. And I introduced one method which I call packing. That's to pack until you have one base equals to one base, one log equals to one log before we can solve the log. So the idea here is that if you remember, I've said before that if a to the power of m is equals to a to the power of n, this implies that m equals to n. All right, okay, given certain conditions as well, where a has to be positive, okay, yeah. And also if log a capital M equals to log a capital N, that this implies that capital M equals to n. So of course, I mean, your m and n has to be positive, your a has to be positive, and your a cannot be equals to 1. All right. So these two ideas that we learned, one learned in topic 3 and one learned in topic 4, all right, gives us the ingredients for us to solve equations, to try to solve for unknown exponents or unknown powers which are hidden, like a and b here, which are basically hidden as unknown powers. So with that, right, I'm going to go into the question. So 3 to the power of a, I'm going to change my 9 to 3 to the power of 2. 3 to the power of 2. Okay. So the reason is because, again, I want to create the same base so that I can pack my terms together. 27 to the power of b, I'm going to write it as 3 to the power of 3. 27 is 3 to the power of 3. B. And this will give me 3 to the power of a equals to 3 to the power of 2 plus 3b. So summoning, I'm going to summon this idea here, this law here, where this idea where a equals to m power m equals to a power n implies that m equals to n. And this allows me to throw away the so-called cancel the bases straight away to equate the powers together. It means that a equals to 2 plus 3b. Okay, the next portion here, log 210 minus 9b minus, again, I can use the idea of the quotient law of logarithms. And in quotient law, we know that log ax minus log ay, this is the same as log a x over y. Okay, so because this is log a x over y, it allows us to combine our term here, right? Basically to log 2 10 divided by 9b minus 2a, which is equals to 1. Okay, so what remains then, now that I have a log function, there are a lot of ways to go about doing it. Some of you may change this to log 2, or I can simply think of converting this to the index form. So if I convert this to index form, then 10 over 9b minus 2a would be equals to 2 to the power of 1. Okay, that would allow me to simplify my equation just algebraically, and 10, I can just divide by 2 on both sides. 5 is equals to 9b minus 2a, and that gives me equation 2, and here I have equation 1. Okay, now just solving these two simultaneously. Okay, I will not go through how to solve simultaneous. I believe you are more than capable to do so on your own. Right, also solving simultaneous equation where you have probably learned in junior high 1 and 2. Right, this will allow you to solve, and you should get the answer simultaneously where a is equals to 11 and b is equals to 3. Okay, right, thank you.